Today I will be performing the wind-up toy lab. So what I'm going to do first thing, just going to sanitize my hands, make sure any of those germs are sanitized so I can touch the lab equipment. So the purpose of this lab is that you will measure the average speed of different wind-up toys. Directions: wind up the toy that is on the table. Set it at the 0 centimeter mark end of the meter stick and let it go. Mark how far it goes and how long it takes in the table below. Then enter the results. In the table below. Alright, so then the first couple of questions are resolution and significant figures. So it says, what is the resolution of the meter stick and can you have an uncertainty digit? Then it asks, what is the resolution of your stopwatch that you're using and can you have an uncertainty digit? And then you will be calculating speed with the data you collect. When you're multiplying or dividing numbers, how many significant figures will your answer have? So you have to look at the rules that we went over in class. Alright, so what I'm going to do is, just to keep it consistent, I'm going to wind up this toy 3 times. 1, 2, 3. Now, at the table what I do is I have a meter stick. I want to make sure it's on the metric side, the meter. I put the 0 up against a book or something. So I know where it started, because some of these toys, they might turn a little bit. I just want to make sure I know exactly where it started so I can put that meter stick up to where it ends. So I'm going to put the toy right back down, wound it about 3 times. I want to make sure I keep that consistent. And I am going to start the timer when I let the toy go. So I know exactly where I started it, and then I'm just going to wait for it to stop. Then I can put that meter stick up to the toy. Alright, so it's continuing to go. This one appears to be going a little straighter than the other ones I have tested out. About 14, 15, 16. There we go. Alright, and stop. Oh, so a little bit off there for a second, but that's one of those sources of that random error. Alright, so this one went about 16 and a half and 26 seconds. But that was just a test. I ran this experiment earlier and I did get some results. So the first time I ran it, it went 27.40 centimeters in a time of 41.43 seconds. And that speed is 0.6614 centimeters per second. And the second time I ran it, it went 17.00 centimeters in a time of 32.93 seconds for a speed of 0.5162 centimeters per second. The third trial, it went 20.00 centimeters in a time of 33.76 seconds for a speed of 0.5924 centimeters per second. And if you averaged up all those speeds, the average speed of the wind-up toy was 0.5900 centimeters per second. Well, then the conclusion, it asks you to identify any random or systematic errors and how you attempted to mitigate them. And then the other one, the last question is, from what frame of reference will all these rates of speed be taken? All right, so now that I've finished the lab, I'm just going to sanitize my hands just to make sure any germs that were on the table are off my hands.